My name is Courtney Payne. I'm a PhD student at Stanford University, working with Kevin at Riga, and I study polar biological oceanography. Today, I will present a project titled Pan-Arctic Analysis of Under-Ice Phytoplankton Bloom Frequency from 2003 to 2020. Phytoplankton are the single-cell plants that live in the surface of the ocean. They are important because they form the basis of the marine food web, and despite accounting for less than 1% of total plant biomass on Earth, they produce half of the oxygen that we breathe and mediate global carbon and nutrient cycles. In the Arctic Ocean, sea ice covers the surface of the ocean for most of the year. This ice attenuates light strongly, reducing the light available to phytoplankton living in the ocean during the ice-covered months. Historically, scientists assume that this lack of light prevented phytoplankton from growing. However, in 2011, observations of a massive under-ice phytoplankton bloom revealed that as sea ice thinned with climate change, phytoplankton have shifted to growing under sea ice. These blooms likely have big ramifications for the food web, but they're difficult to observe. Here, I used satellites to assess where under-ice and marginal ice zone blooms were generated. I did this by looking at remotely sensed chlorophyll concentration, which is an indicator of plant biomass, at around the time of ice retreat. If chlorophyll concentrations dropped following ice retreat, I assumed that an under-ice bloom was generated. If instead chlorophyll concentrations increased following ice retreat, I assumed that the bloom was generated in the marginal ice zone, or the MIZ. I classified every pixel in the Arctic Ocean as having either an under-ice or marginal ice or an open water bloom, as well as having no ice or no observations for the years from 2003 to 2020. In my research, I found that pixels with no ice cover, with under-ice blooms, and with marginal ice blooms all saw an increase over this period. However, because the total number of pixels in my analysis increased due to greater sea ice retreat over time, the increase in under-ice blooms was offset, so the proportion of under-ice blooms was unchanged over this period. However, under-ice blooms did change proportionally at some latitudes. In the southern Arctic, under-ice blooms diminished over time, while at northern latitudes, they increased. This likely will have profound implications for marine organisms and for biogeochemical cycling in the Arctic.